Welcome to the live interactive session for the course Surface Water Hydrology. Today in this week we will be focusing on the analysis of hydrograph part 2. This course is being taken by Professor Dr. Rajiv Maiti from the Department of Civil Engineering IIT Kharagpur. I am the teaching assistant Aman Srivastava, and let's resume solving the problem on unit hydrograph. And today we will be focusing on two aspects, that is the method of superposition and S-curve. So let us start with the first question on method of superposition. Let me read the problem. Ordinates of a 1 hour unit hydrograph at 1 hour intervals starting from time t equal to 0 are 0, 9, 15, 11, 7, 5 and 0 meter cube per second. Compute the ordinate of a 4 hour unit hydrograph for the catchment at t equal to 6 hours. So here they have provided the time from t equal to 0 to t equal to 6, and they are expecting, in this problem it is expected that we should convert this 1 hour unit hydrograph into 4 hour unit hydrograph. So let us see how we can utilize the method of superposition to solve this problem. Okay, so here we have solved this problem. So let us try to understand how we have actually generated the ordinate of 4 hour unit hydrograph from the ordinates of 1 hour unit hydrograph. So here this is the problem. It is at 0 to 6 hours. The ordinates of 1 hour unit hydrograph was already provided in the problem, right? So now in order to get the 4 hour unit hydrograph, we first lagged the ordinates of 1 hour unit hydrograph by 1 hour. So instead of writing 0, 9, 15, 11, 7, 5 exactly corresponding to 0, 1, 2, 3, 4, 5, we have lagged it by 1 hour. So now we are writing 0 at 1 hour, then 9 by at 2 hour, and 15 at 3 hour, and so on. So in this way we have lagged the ordinates of 1 hour unit hydrograph by 1 hour. Likewise, we have now lagged it by 2 hours. So keeping these two boxes blank, we will start writing the ordinates of 1 hour unit hydrograph from 2 hours. And likewise, now we have lagged it by 3 hours. Right, so all together we can see here that this is the ordinates without any lag. This is ordinate by 1 hour lag. This is the ordinate by 2 hour lag, and these are the ordinates at 3 hour lag. So when we add all these ordinates together, we get the direct run of hydrograph of 4 centimeter. So here this is 0, and here this is 9 plus 0 is equal to 9. Then this is 15 plus 9 plus 0 is equal to 24. Likewise, 11 plus 15 plus 9 provided as 35, and so on and so forth. And then how to identify the ordinate of 4 hour unit hydrograph, because it is 4 centimeter, it is for the cumulative depth of rainfall, that is 4 centimeter. So now dividing each of the ordinates of direct run of hydrograph by 4, we get the ordinates of 4 hour unit hydrograph. So 9 divided by 4 provides 2.25. Likewise, 24 divided by 4 gives 6. 35 divided by 4 gives 8.75, and so on and so forth. Now in the problem it has been asked, like, what is the corresponding ordinate of 4 hour unit hydrograph at time 6 hours. So here I have highlighted in yellow, and the answer is nothing but 5.75 meter cube per second is the ordinate of a 4 hour unit hydrograph corresponding to the time 6 hours. So I hope you were able to follow the method of superposition in solving the problem of converting ordinates of 1 hour unit hydrograph into ordinates of 4 hour unit hydrograph. Moving ahead, let's solve another problem on the method of superposition. Let me read the problem. The 6 hour unit hydrograph, that is U1, triangular in shape, has a catchment of area 450 km square and the peak discharge of 50 meter cube per second. For another catchment, a 6 hour unit hydrograph U2, which is also triangular in shape, has the same base width, that is as U1, but with a different peak flow of value of 100 meter cube per second. Estimate the base width and catchment area corresponding to U2. So this is what is the target, to find out the base width and the catchment area of the unit hydrograph 2, U2. I hope you remember in the previous lecture we saw how to actually utilize the properties of the triangular unit hydrograph in order to find out various aspects of unit hydrograph, such as discharge or the base width or the area of catchment, etc. So keeping those understandings in mind, let's solve this problem. Let's move to step number 1, which is to find out the base width of the 6-hour unit hydrograph U1. So ultimately we need to find out the same for U2, but let's start with U1 given the properties which are provided in the problem. This can be obtained by using the same understanding that we actually utilized in the previous lecture. Volume under 6-hour unit hydrograph for U1 is nothing but is equal to the area of catchment into effective rainfall of unit depth, that is 1 centimeter. So half into base width, that is the time base, into the height, which is 50 meter cube per second, which is provided. So we have converted it into standard units, that is seconds. And here the area of catchment was also already given, 450 kilometer square, has been converted into meter square, and this depth has been converted into meter. And solving this, we get the base width of 50 hours. This is what the answer because the base width of unit hydrograph 6-hour unit hydrograph U2 is also same as unit hydrograph U1. So that is the base width 50 hours. Now let's find out the catchment area of the 6-hour unit hydrograph U2. For this, since we know that the base width remains the same for both U1 and U2, and the only component which was changing was the peak discharge. So now again, utilizing the same property, now we have written here that the base width is 50, that we are utilizing from step 1, and 100 meter cube per second is the peak discharge which was for U2. And what is unknown here is the area of catchment. Area of catchment of U1 is known but not the U2, right? So here we could have written U2 as well in order to get the understanding for U2. Now the area of U2 is unknown, that is what we need to find out, and effective rainfall is same as effective rainfall for U1 because we are dealing with unit hydrograph. Solving this, we get the area as 900 km square, which is the response, is the final response for the 6-hour unit hydrograph U2. I hope you were able to understand this problem and also learn how to utilize the property of the triangular unit hydrograph in this case as well. Moving ahead, now let's solve one problem on S-curve technique. Let me read the problem. The 6-hour unit hydrograph for a catchment is given in the table below. What would be the maximum ordinates of the S-curve in meter cube per second derived from this unit hydrograph? Okay, so our goal here is to develop a S-curve for this given ordinates. So here the time is given at the interval of 3 hours under 36 hours, and the corresponding unit hydrograph ordinate is also provided in meter cube per second, which is 0, 2, 6 and so on. So now utilize this information to develop the S-curve. So let us revisit some of the lecture slides that was being taught by Professor Rajiv Maiti. Here we studied the construction of S-curve. So we have already discussed that S-curve is obtained by adding a string of d-hour unit hydrographs, each legged by d-hour from one another. So this can be summarized using this equation, that is ut is equal to st minus st minus d. Right, so here this st minus d is nothing but the S-curve time addition. Right, so this equation can be rewritten as st is equal to ut plus st minus d. Right, so here st is nothing but it's the ordinate of the S-curve, that is the final S-curve that we want to obtain, and this ut is nothing but the ordinate of a unit hydrograph, which is already provided in the problem, and st minus d is the S-curve time addition. Right, so this is the equation that we need to utilize to develop the S-curve or to construct the S-curve. Again, since there is another property that need to be retained here, is like if the time for which we are developing the S-curve is less than or equal to the d-hour duration that for which we are actually solving the problem, then the S-curve addition is also becoming 0. So if t is less than or equal to d, then the S-curve addition, that is st minus d, will be 0. So now let's see how we can use this information to actually construct the S-curve for the given problem. So here is the solution. Now let's try to interpret the solution. Here, if we look carefully, since we need to construct the 6-hour S-curve, and we can see here that if the time t is less than or equal to the d hour, and here d is nothing but 6 hours, then we have to consider S curve addition as 0. So you can see here that for the time 6 and less than 6, the S curve addition is 0. I hope you were able to follow this. Now for the time of 9 hours here, the 9 minus 6, that is a 6-hour duration, which is the standard. So 9 minus 6 gives 3 hours. So corresponding to 3 hours, we have unit hydrograph ordinate of 2 hours, which has been transferred here. So corresponding to 9-hour duration, the S curve addition will be 2. I hope you understood this. Next, for 12-hour time, so 12 minus 6 provide us 6. So corresponding to 6, we have the unit hydrograph ordinate of 6 and the S curve addition is 0. So 6 plus 0 gives 6, which is what has been written corresponding to 12-hour duration. Likewise, for the 15-hour duration, so 15 minus 6 gives 9. So corresponding to 9, now we have unit hydrograph ordinate of 10 meter cube per second, as well as we have the S curve addition of 2. So 10 plus 2 gives 12, which is what is written here. And likewise, we will keep solving this to get the S curve addition. Once we have obtained this entire column of the S curve addition, what we can do next is to obtain the ordinates of S curve. So it is now a very simple step. Just we need to add the unit hydrograph ordinate with the S curve addition to get the ordinate of S curve in meter cube per second. So 0 plus 0 is 0, 2 plus 0 is 2, 6 plus 0 is 6, 10 plus 2 is 12, 19 plus 6 is 25, and so on and so forth. So here we can see that the maximum value of the ordinate of S curve that we can obtain is 44. So 44 meter cube per second is the final response. I hope you were able to understand how the S curve is being constructed by using the concept of S curve addition. So in this lecture, we focused on two methods, that is the method of superposition and S curve construction for unit hydrograph. I hope you were able to understand both of these problems. Stay tuned for more videos on surface water hydrology. Thank you.